Hello Doctor, this presentation video is from Group Hanabi. My name is Yusi Xiong and I would like to introduce my other three group members, Adiba, Hafiz and Jaji. So today we would like to present about the topic fixed and dynamic memory arrangement of the NextFit and WorstFit. So firstly, I would like to introduce what is memory arrangement. Memory arrangement is responsible to manage the primary memory in the computer. So in order to arrange the memory, so we will use a method called contiguous memory allocation. So this method is to allocate a single contiguous section of the memory. In the memory allocation, the memory will be divided into several fixed size partitions. Each partition represents a process. So when a process wants to finish their job by entering the system, it will be put into an input queue first, which is the job list. Then the operating system will determine the memory requirement of the process and also the memory space available in the system, which is the hole. So if the hole is suited to the process, then the system will allocate the process into that hole. So when the process is finished and executed, then the system will add another process into the main memory. But there is a problem when the process terminated. So if the process terminated and the new hole is next to the other hole, then they will be combined together and become a bigger hole. So the system will need to check again the input queue from the start until the end of the job list. So this kind of problem is called dynamic storage allocation problem. However, there are some solutions can solve the problem. So the solutions are the first fit, best fit, next fit, and worst fit. So today we will only discuss about the next fit and the worst fit. That's all for my part about the introduction about the memory arrangement. Next, I would like to let Hafiz and Jaji explain more about the next fit and the worst fit. Thank you.
Assalamualaikum and a very good day. My name is Muhammad Hafiz SECR2043 and I'm gonna explain about the NextFit memory management algorithm. So in this memory algorithm, the NextFit, I'm gonna first explain about how the code works and then I'm gonna show the running program. So the memory, so the data that we use is this one. So the whole that is present right now, there's 200k, 500k, 100k, 350k, 300k. This is the memory partition, and then there's also the process that we need to do. There's 100k, 300k, 60k, 90k, 200k, and then this is the code that I already written to show the NextFit algorithm. So this is the function to allocate memory blocks using NextFit algorithm. So the main function only have the driver program. It's gonna first declare the block size that already being explained before. So this is the block size, and then there's the process size like 100, 360, 90, 200. This is the process size that we need, and then there's the M and N. This is the size of block and the size of process, and then it's gonna pass it to the function, and this function asks for 4 parameters from the main function. It asks for the block size, and then it's asks for the integer M, integer process size, and in array. Both of this is in array, and then the integer N. So first it's gonna store the block ID of the block, then allocate it to a process. So allocation and it's gonna set the J to 0, and initially there's no block assigned to any process, so it's gonna assign the first block. So it's like the first the first fit, and then it's gonna pick each process and find suitable blocks according to its size and assign to it. So it's gonna do a for loop, and it's gonna check, it's gonna do also a while, so it's gonna start from the beginning, and then it's gonna check if the block size of J is greater than the process size of E. Then if it is, it's gonna allocate the block J to PI process, and then it's gonna reduce the available memory in this block. So, and this modulo, it's gonna help in traversing the blocks from starting block after we reach the end. So and then after all of this for loop have been done, and all of the memory have been assigned to the all of the process have been assigned to the block, it's gonna print out of the process size and also the block number that it's going to. So I'm gonna compile and run, and we're gonna see. Okay, so we have process number, process number 1, that is 100, and it's going to block number 1. So this is the initial first fit. It's gonna go to the first, and then for the next fit, it's gonna start from the 100, and there's the process size of 300. It's gonna go to the block number 2 because it's 500. It still hold the 300 there, and then after the 300 there's 60, the process size of 60, and process size of 60, it's still on the it can be fit in here. That's why it's still in the block number 2, and then there's 90, so 360 is still 360. Added with 90, it's gonna be 450, and it's gonna still fit in this block number. That's why it's still 2. And then after that there's the process size of 200. It's gonna go to block number 4 because in block number 3 it's not gonna fit because this is 200 and the block only hold for 100k. That's why it's gonna go straight to block number 4 because this can hold 350 and the process size is 200. So yeah, that's the explanation about, and also the example of the coding for the NextFit algorithm. Thank you very much.
Hi, my name is Deng Jiajing and I'm from group Hanabi. So in this part, I will going to explain the WorstFit allocation in the fixed and dynamic memory management. So what is WorstFit? WorstFit is an algorithm that searches for the free space in the memory in which it can store the desired information, and this algorithm will select the largest hole, or we can say the largest possible free space in the memory so that the information can be stored. And this algorithm will search the entire list of the block in order to find the largest hole. Next, we will look at an example of WorstFit allocations by assuming fixed partition. Here we have an operating system with the memory partitions with different size of unused memory, and we need to allocate these process into the memory. Here we have 5 processes with the different size, and according to the WorstFit algorithm, we need to search through the entire list to get the largest hole. So we need to allocate the process 1 into the memory, and the largest hole in this memory is 500. So now we allocate process 1 into the second block, and now the internal fragmentation is 400k, and we move on to the process 2 with the size of 300k. So now the largest hole in this memory is 350k, and the process 1 will be allocated into the fourth block. Same goes to the process 3 and process 4. It will be allocated into the last block and into the first block. So now we can see that there is not enough space for the process 5, since the largest hole now in the memory is only 100k. So P5 has to wait another process to complete their task so that the P5 can allocate into the memory. So now next we will look at another example of WorstFit allocation by assuming dynamic partition. We will use the same data set from the previous example, same as before. P1 will be inserted into the 500K, which is the second block, and now P2 with the size 300K will be inserted to the second block with the internal fragmentation of 400K. Then P3 will be inserted into the fourth block with the largest hole, which is 350K, and same goes to P4. And now P5 will be inserted into the internal fragmentation of the fourth block, which is 290K. So that is the difference between the dynamic partition and the fixed partitions. Dynamic partitions will search through the entire list, including the internal fragmentations, but the fixed partition only search through the external partition. So now we are going to look at the WorstFit implementations by using the C++ coding. So first we will insert the dataset into the array block size and the array process size. So we will focus on the function of WorstFit. So this function is to allocate memory to blocks, as we will gonna use the WorstFit algorithm. So in these functions, we have the nested loop inside. So this nested loop is to pick each process and find the suitable blocks according to its size and assign to it. So now we will try to trace the loop in order to have a better understanding. So initially we will set the worst index equal to -1 because there's no worst index in the process. So we will try to trace when j equal to 0. So is block size array 0 greater than block size array 0? So we will look at the data inside the array. So yes, 100 is greater or equal to the 100. So this statement is true, and we will go inside the statement. So is worst index equal to -1? Yes, because initially the value of worst index is -1. So we will assign the worst index equal to j. So our j now is 0. So the worst index now is 0. So and then the value of j will be updated to 1 since j++. So now j equal to 1. So is block size array 1 greater than block size array 0? So yes, the block size array 1 is 500 and it is greater than 100. So this statement is true, but this statement is false because we update the value of the worst index now become 0. So now we go to the statement in this statement. So it's block size worst index. So worst index is 0. So block size array 0 smaller than block size array 1. So the statement is true because 100 is smaller than 500. So this worst index, the value of the worst index will be updated equal to j. So the worst index now is j. So this loop will continue until the j is smaller than m. M is actually the number of the elements in the block size. So after we get the worst index, and we will, if we could find a block for the current process, and then we will allocate the block to the process, and then we will reduce the available memory in this block. So now we will try to run this program in order to get the result. So here we can see each process has been allocated into the block number, and actually this code is based on the dynamic partition.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adiba Astavinti Shamsuri. I am going to present a comparison between NextFit and WorstFit. For the comparison of the NextFit and WorstFit, first we look for how the job will be allocated. So the job for NextFit will allocate it to the first hole that is big enough. But for the WorstFit, the job will allocate it to the hole that we produce the largest leftover. For the NextFit, it is a modified version of the first fit, where for the WorstFit, it is the reverse version of the best fit. NextFit search will start from a last hole allocated, but for the WorstFit, the searching must do to the entire list. For NextFit, it used the memory efficiently but slower in implementation, where for the WorstFit, it did not use the memory efficiently because it will produce a larger internal fragmentation. Now we go to the advantages and disadvantages of the NextFit and WorstFit. First, for the NextFit. Advantages of the NextFit is that it can avoid the usage of memory always from the beginning of the free blockchain, and straight and faster than FirstFit and BestFit. But we look for the disadvantages. It tends to cut large portion of the free parts into small pieces and may lead to more internal fragmentation at the beginning. For the WorstFit, the advantages of the WorstFit is it can reduce the production of small gaps, and disadvantages are if a job allocated requiring larger memory arrives at a later stage, then it cannot be accommodated as the largest whole is already split and occupied.
As conclusion, we know what are the NextFit and the WorstFit in the memory allocation. We also know what are their advantages, disadvantages, and the comparison between them. So the memory arrangement is important because it affects the time execution of the process. In order to have an effective memory management system, we must make sure that the data inputted from the secondary memory to the memory are accuracy, availability, and consistency. So that's all for our group presentation on this topic. Thank you for watching, and that's all.